Hello Prealgebra students, this is lesson 26 and our objective is what are the different kinds of transformations, and then of course I guess how do we kind of identify them and work with them a little bit. There's four kinds of transformations. The first one is a translation, or simply a slide, where it takes one shape and slides it to another place. It's called a translation. These shapes should be congruent. And this first shape, the one we start with, is called the pre-image. And the second one is called the image. Just kind of like you take a picture of someone and you print it and you call that an image of them. It's not actually them, it's the kind of copy of them. And so this first one we just use like letters A, B, and C. And then the image, the pre-image we use normal letters. The image we use little prime marks. So this is the image of that one. And we call these points like A prime, B prime, C prime. So that's the first kind, it's just a translation or a slide. Next time is a rotation. So notice this one here got spun around over to here. So this point A is down over here. A prime. B came up here. B prime. C came down here. C prime. So again, these two shapes are congruent, but they're just turned. The rotation of the other one. The next one is a flip, so kind of like across a line. Sometimes it's across the edge of a triangle. So it flips across. So this is A to A prime, B to B prime all the way out here, and C to C prime. So this is a reflection, right? A mirror image of itself, or flip. And again, these are congruent. And since all three of these are congruent, they all fall into this category, what we call an isometric transformation or congruent transformation. So those three are kind of all grouped together. We'll work with those first on the next page. And then the other kind is what we call a dilation, or like an enlargement or a reduction. A dilation is kind of the generic term for that, where you take a shape and it still is the same shape, but now it is bigger. And this is what we call a similarity transformation. A similarity. And these shapes are similar to each other but not congruent. So let's work with those first three like we mentioned. We're supposed to describe the transformations that move triangle ABC to the location of A triple prime, B triple prime, C triple prime. Now a little hint is that these have three prime marks, and probably it went through three different transformations to get to here. Now, it's not always the case, but just for this one, it's a hint. So there's probably a couple different ways we can get from this one to this one. So I'm just going to give you one suggestion. You could probably come up with other ones. So first of all, I'm noticing I'm going to have to turn this. So let's notice we kind of just turn it so that way this line CB comes to right here, and then this point would be coming out to here. So I just go to here. So this would be A prime, this would be C prime, and B prime actually be the same, B and B prime. B and B prime. So the first thing is a rotation, 90 degrees, right? Because I went from straight vertical to straight right. Notice this line right here went from straight vertical to pointing straight right. 90 degrees in what direction? Clockwise. Because we went down to the right. That's the same way that clocks turn. And then we're not quite there yet, or we could even say rotation 90 degrees clockwise. We could say about the point B if we wanted. I'll go write that in. About point B. I wouldn't mark you off too much if you didn't have that. And then notice now this C is on top, and this C is on the bottom, but the A is on the right side. So now we need to reflect it. So next part is going to be a reflection across line AB. So across this line. So AB is going to stay the same. We're going to reflect it across that line, so it's going to come down to here now. So A is also going to be a double prime. B and B prime is also going to be B double prime. And C prime is going to come down here to be C prime. Now, we're in the correct position. My triangle's in the correct position, but needs to slide over to this new position. So now let's just see here. We went 1, 2, 3, 4, 5 spaces to the right. So now we're going to do a translation. 5 units right. And how far down we go? 1, 2, 3, 4. 4 units down. And that same thing should work like if we do C. If I go right 1, 2, 3, 4, 5 and down 1, 2, 3, 4. Ends me up there with C triple prime. And then same thing with B. 1, 2, 3, 4, 5 down 1, 2, 3, 4. Gives me that B double prime, triple prime. So I've described it. You probably could have gone in a different order or a slightly different way, but you get the basic idea there. And then here's one with a dilation. It says use a scale factor of 4 to find the image, so that's the new one, of rectangle WXYZ. So they have this rectangle here of WXYZ that's 3 inches tall and 10 inches wide. So I'm just going to draw a sketch here of my new one. I know it's going to be 4 times as tall and 4 times as wide. So this may not be exactly to scale, but there we go. Just a rough sketch. In fact, that's actually what they ask us to do right here, is sketch this new one. So this point right here is going to be what we call X prime. This point here is what we call Y prime. This one would be W prime, and this would be Z prime. Too bad we don't have an Optimus point. And our height is 3. Our height is 3. So if I want to find the new length, I'd use the scale factor. So I'd say 3 inches times 4 would give me my new height. Well, 3 inches times 4 is going to equal to 12 inches. Something similar for the length here. I have 10 inches times 4 would give me 40 inches. Okay. And then, so that is a sketch that they ask us to do here for this first one. So there's a sketch of it. What is the perimeter of each? So let's find the perimeter of the smaller one first. The perimeter is going to be 10 plus 10 plus 3 plus 3, so it's going to be 26 inches. And the perimeter of the big one is going to be 40 plus 40 plus 12 plus 12. So this part is 80, and this part is 24. So my perimeter is going to be 104. So, and then it says, what is the scale factor of the perimeters? So 26 times what is going to give me 104? Well, let's see, if it's 25 and 100, it'd be 4 times. So does that work? 26 times 4 gives me 104. Well, yes, it does. So, and this is inches, by the way. So what's the scale factor? The scale factor is 4. Alright, and then the next one says, what is the area of each? So let's talk about the area. Remember, area is just base times height. So and this one's going to be 10 inches times 3 inches, which is going to give me 30 inches squared. And the area of this one is going to be 40 inches times 12 inches, which is going to give me 480 inches squared. And then if I want to find the scale factor, which is what it's asking us to do now, what's the scale factor of the areas? So I'm trying to figure out 30 times what is going to give me 480. The other way to figure that out would be to say 480 divided by 30. And whenever I divide that by 30, I get 16. So the scale factor is 16. And just on a side note there, 16 is equal to 4 squared. I don't know if you see any kind of pattern in that. But I think that it brings us to the end of our lesson. Your homework is on page 173. You're going to need to do the practice set, all of them from lesson 25, and then 11 more of your choice. Good luck. I'm sure you're going to do awesome.